The sun has endured cosmic insults for 4.6 billion years, rogue asteroids, titanic solar flares, even close brushes with wandering stars, but it has never faced anything like 3I/Atlas. This interstellar intruder carries with it a chemistry and velocity foreign to our solar system, a visitor forged in the furnace of a long-dead sun, and it is heading toward our star with a trajectory that makes even the most seasoned astronomers whisper the word no one wants to hear: destabilization. If Atlas approaches too close, it won't just be another cometary fireworks show. It could become the trigger for solar violence on a scale we've never witnessed in human history. Think less about a glowing streak in the night sky and more about a potential chain reaction that shakes the sun's delicate magnetic balance, unleashing radiation storms powerful enough to fry satellites, strip atmospheres, and reset the conditions for life itself across the inner planets. On paper, this should be impossible. The sun is a titan, 100 times wider than Earth, and so massive it accounts for 99.8% of the solar system's weight. Compared to that, Atlas is a mere speck of dust. But interstellar objects aren't like the sleepy comets born in our Oort cloud. Their velocities are higher, their compositions are stranger, their behavior is unpredictable. And the sun, for all its stability, is also a star perched on a razor's edge of magnetic chaos. One push in the wrong place at the wrong time, and the consequences could ripple outward through the entire heliosphere. The worst-case scenario isn't just a spectacular flare. It's a system-wide catastrophe, a solar tantrum that bathes every planet in lethal radiation and turns Earth's fragile web of technology into smoking ruins. This is not science fiction. It is the unsettling reality that astrophysicists are quietly debating, running simulations late into the night, and refusing to publish in plain language for fear of public panic. Tonight, we'll peel back the layers of reassurance and examine the nightmare scenarios. What if Atlas fragments in solar orbit and feeds the sun more plasma than it can handle? What if it triggers magnetic reconnection events that make the Carrington event of 1859 look like a sparkler? And most haunting of all, what if the danger isn't in the comet's mass, but in the alien chemistry it carries, catalysts that could alter the sun's fusion envelope in ways no model has ever accounted for? Stay with me, because the most terrifying possibility is not that Atlas destroys itself in the sun's fire, but that it teaches the sun how to destroy us. The sun is not a gentle parent star quietly nourishing its planets. It is a raging nuclear inferno, a 1.4 million kilometer wide furnace of hydrogen plasma blasting out 386 billion megawatts of power every second. To us on Earth, it seems stable, eternal, predictable, but astronomers know better. The sun is a predator with a hunger that never sleeps, and when an object like 3I/Atlas strays too close, the consequences spiral into scenarios that range from dazzling displays of cosmic beauty to civilization-level catastrophes. At its core, this question isn't just about whether Atlas survives the encounter, it's about whether our sun itself will be provoked into chaos. And to understand that, we have to dive into the brutal physics of what happens when an alien interstellar comet dares to trespass on the solar threshold. 3I/Atlas is unlike any comet we've cataloged before. Its coma already stretches millions of kilometers in defiance of the norms we expect, dwarfing the scale of most near-solar objects. This is a body that evolved far outside the neat gravitational classroom of our solar system. It was shaped by radiation from another star, under different chemical laws, with isotopic ratios we've never measured in anything local. NASA estimates its outgassing rates could exceed 10,000 kilograms per second of carbon dioxide and methane-rich ices, numbers so absurd that some planetary scientists privately compare Atlas to a cryovolcanic bomb on a cosmic timer. Now imagine those volatile compounds injected directly into the ferocious heat of the Sun's inner domain. As Atlas approaches perihelion, the surface temperature of its nucleus would surge to 2000 K or more, hot enough to not just vaporize ice, but shatter crystalline lattices of exotic interstellar minerals, triggering chain reactions of explosive outbursts. This isn't sublimation, it's detonation. The Sun reacts violently to such intrusions. Historical data from sun-grazing comets like iSun in 2013 and Lovejoy in 2011 reveal that as their volatile tails whipped through the solar corona, they created massive magnetic disturbances, temporary knots in the Sun's own electromagnetic fields. Those disturbances acted like flares, releasing bursts of energy measured in 10 circumflex, 25 joules, a scale comparable to the detonation of 1 billion hydrogen bombs. Now take those past events and scale them up to an object 5 times more active and 10 times more chemically unstable. Atlas wouldn't merely skim the Sun, it would inject chaos into the very plasma streams that govern solar weather. The tails of ordinary comets stretch millions of kilometers. Atlas's ion tail, driven by its alien chemistry, could span tens of millions of kilometers, enough to braid itself into the Sun's Parker spiral magnetic field and destabilize it across planetary distances. The nightmare scenario is this: Atlas plunges within 0.1 AU of the Sun, its nucleus fragmenting under tidal stresses and thermal extremes. Each fragment becomes a miniature plasma engine, spraying ionized material directly into the solar wind. That injected plasma, rich with compounds Earth has never seen, collides with existing solar flows, creating turbulence so intense it could trigger a chain of coronal mass ejections, CMEs. These CMEs, hurled outward at 2,000 kilometers per s, would slam into the heliosphere with such ferocity that Earth's magnetosphere might compress to half its normal diameter. Satellites in geosynchronous orbit would be roasted in electromagnetic storms. GPS signals would collapse, and power grids from North America to Europe could overload in cascading failures. We've modeled what a Carrington-level event could do to our civilization, but an Atlas-enhanced solar storm might be 10 times stronger, capable of setting modern infrastructure back to the 1800s in less than a week. But here's where the story takes a darker turn. If Atlas carries exotic isotopes, say radioactive nuclides forged in the heart of supernovae, those could act as catalysts in the solar plasma, creating fusion anomalies on a local scale. To date, no comet has ever been large or alien enough to alter the Sun's surface behavior beyond temporary disturbances. Yet Atlas, with its colossal volatile inventory, might change that rule. Imagine localized hotspots on the Sun, flaring beyond anything we've ever seen, effectively creating artificial sunspots that spiral into superflare conditions. A superflare is not just a solar tantrum, it's an event where the Sun's luminosity spikes by several % for hours or days, releasing as much energy in a single burst as our star normally emits in a century. Geological evidence suggests superflares have occurred on Sun-like stars. What if Atlas, our interstellar intruder, is the spark that turns speculation into reality? The timing could not be worse. The Sun is entering its peak solar cycle between 2024 and 2026. Already, we've seen an increase in X-class flares and magnetic instabilities. Atlas's arrival in this volatile period is like tossing a canister of jet fuel onto a bonfire. Even a modest gravitational or electromagnetic disturbance could cascade into systemic solar instability. And the terrifying part is this: we would have almost no way to stop it. Humanity can deflect asteroids. We can track near-Earth objects with decades of preparation. But we have no defense against a star that decides to erupt. The worst-case scenario is not that Atlas is destroyed by the sun, but that in dying, it makes the sun itself more dangerous for every planet orbiting it, including Earth. If Atlas ventures too close, the laws of celestial mechanics predict a sequence of events more harrowing than science fiction. At its perihelion, the comet may not simply disintegrate gracefully like a snowball in a furnace. Instead, tidal stresses from the sun's gravitational well, capable of pulling an object apart with forces exceeding 10 circumflex, 11 newtons, could fragment Atlas into dozens, perhaps hundreds of pieces. Each fragment would follow its own death spiral into the solar inferno, some vaporizing instantly, others surviving long enough to inject entire rivers of plasma into the corona. The sun would, in effect, be fed a banquet of alien chemistry, delivered not as a single impact, but as a relentless series of collisions spread across days or weeks. Every fragment would unleash energy equivalent to gigaton-class nuclear detonations as its volatiles flash boil in contact with the corona. The combined effect would not be a singular event, but a drawn-out crescendo of chaos, the sun ringing like a bell under the impacts. Solar physicists worry about resonance, just as a bridge can collapse when vibrations align with its natural frequency. So too can solar magnetic loops destabilize when external energy arrives at just the wrong intervals. If Atlas's fragments struck in rhythm with existing magnetic oscillations, we could see solar loops tens of thousands of kilometers high, snapping violently, releasing CMEs in synchronized waves. Instead of one Carrington-level storm, Earth could be hit by a barrage of storms, each separated by mere days, giving satellites and power systems no chance to recover before the next blow arrives. And then comes the radiation. Each Atlas-induced CME would blast the solar system with proton fluxes measured in the trillions. Earth's magnetic shield can withstand ordinary bursts, but repeated assaults compress the magnetosphere like a balloon under pressure. At 10% of its current thickness, low Earth orbit satellites would be exposed directly to cosmic radiation. Astronauts aboard the ISS, or worse, future crews en route to the Moon or Mars, would receive lethal doses in hours. Airline passengers flying polar routes would be hit with radiation levels exceeding modern nuclear accident thresholds. The sun's X-ray and gamma-ray output could spike high enough to ionize Earth's upper atmosphere, erasing entire layers of the ozone shield in days. The result? Surface UV radiation so intense it could sterilize crops, blind animals, and trigger a mass extinction cascade. But this isn't just Earth's problem. Jupiter's magnetosphere, the largest structure in the solar system, could funnel Atlas-induced solar storms into auroras so violent they would outshine Venus in our night sky. Saturn's rings, delicate and fragile, might be bombarded by plasma flows strong enough to erode their icy particles, darkening them permanently. Even Pluto, sitting on the edge of the Kuiper Belt, would feel the touch of this alien comet's sacrifice, its thin atmosphere blasted away by waves of solar particles traveling billions of kilometers. The entire solar system would become a storm-tossed ocean, its planets lashed by currents of fire, unleashed not by the sun alone, but by a visitor from another star. And the ultimate terror? Feedback. Some models suggest that if enough energy is dumped into the solar corona in a short enough time, it could destabilize not just the outer atmosphere, but deeper fusion zones. That doesn't mean the sun would explode like a supernova. It doesn't have the mass for that. But it could flare into a hyperactive state, doubling or tripling its normal output for months or years. Earth's climate systems, finely tuned to the sun's steady output, would spiral into chaos. Oceans would heat rapidly, polar ice would collapse, weather systems would destabilize into permanent superstorms. Civilization, dependent on fragile infrastructure and predictable growing seasons, might unravel, not because a comet hit Earth, but because a comet provoked the sun into a state we have never witnessed in human history. And the cruelest irony? From Earth, much of this would look beautiful. The skies would erupt with auroras, seen even at the equator. Nights would glow faintly as the upper atmosphere ionized continuously. Amateur astronomers would cheer at the sight of Atlas's fragments, streaking across the sun's limb. All the while, the seeds of catastrophe would already be in motion. By the time humanity realized the full scale of what was happening, it would be too late. Atlas's death spiral would already have reshaped the star we orbit, and in doing so, rewritten the conditions for life in the only solar system we've ever known. The word superflare sounds like science fiction, the kind of phrase you'd expect to hear in a pulp novel or a doomsday film. But superflares are very real, and the astrophysical record is merciless in its testimony. Observations from the Kepler Space Telescope have revealed that stars like our Sun are capable of producing bursts of energy 10 to 1,000 times stronger than the most violent solar flares we've recorded. Imagine the Carrington event of 1859, the geomagnetic storm that set telegraph wires on fire across continents and created auroras visible in the Caribbean. Now multiply that by 100. That is the scale of destruction a superflare would unleash, and the chilling question is whether 3I/Atlas could become the cosmic trigger that wakes this sleeping giant inside our star. The mechanics of a superflare are rooted in magnetic reconnection. The sun's magnetic field is a labyrinth of twisted lines, coiled like springs by differential rotation and plasma flows. Under normal conditions, these loops snap and release bursts of energy we see as solar flares. But in a superflare, the buildup of magnetic tension becomes so extreme that the entire surface of the star reorganizes itself, unleashing energy equivalent to 10 circumflex, 36 joules, enough to power human civilization for 1,000,000 years, released in a single day. Now here's where Atlas enters the picture. As the comet plunges close to the sun, its massive ion tail, tens of millions of kilometers long, doesn't just drift passively in the solar wind. It acts as a conductor, a dynamic ribbon of plasma dragging through magnetic field lines, like a wire short-circuiting a power grid. NASA's Heliophysics division already warns that even small sun grazers can distort local solar fields. But Atlas isn't small. It's a runaway interstellar battery loaded with exotic isotopes, outgassing in unpredictable bursts. It could act as a match tossed into a powder keg that has been waiting for centuries to ignite. If the sun were to superflare, Earth would face consequences beyond the imagination of disaster planners. The electromagnetic pulse alone would be enough to fry every unshielded electronic device on the planet. Power grids, satellites, aircraft, ships, all of them would be reduced to silent relics. Within hours, modern civilization would be stripped of its nervous system. but the electromagnetic chaos would only be the opening salvo. A superflare bathes planets in hard X-rays and gamma rays, radiation strong enough to rip molecules apart in the upper atmosphere. Earth's ozone layer would vanish in weeks, leaving the surface exposed to sterilizing levels of ultraviolet light. Crops would wither, animals would go blind, cancers would explode in frequency. The world would enter a biological crisis not seen since the Permian extinction 250 million years ago, when 90% of species disappeared. And let's not pretend Mars or the outer planets would be spared. Mars, with its non-existent magnetosphere, would be blasted raw. Its tenuous atmosphere, already fragile, would be shredded down to near nothing, rendering future colonization impossible. Europa and Enceladus, icy moons that harbor subsurface oceans, would see their protective ice shells baked and cracked by radiation fluxes, boiling away any hint of habitability. Even Pluto, billions of kilometers away, could lose what remains of its thin nitrogen atmosphere. An Atlas-triggered superflare wouldn't just be an Earth problem, it would be a solar system extinction-level reset, rewriting the atmospheric and magnetic histories of every world that circles our star. Now here's the detail that keeps astrophysicists awake at night. Superflares leave scars. Evidence from tree rings on Earth suggests that smaller, yet still monstrous, solar storms have already brushed our world in the last few thousand years. A sudden spike in carbon-14 levels around 774 AD indicates a solar event so powerful it may have been a mini superflare. If Atlas serves as the trigger for a true one, it could set a precedent for centuries of instability. Once the sun is pushed into this hyperactive mode, it might not calm down for decades, maybe centuries. We'd be forced to live under a star that has turned from a benevolent provider into an unpredictable executioner, delivering wave after wave of chaos, as if Atlas had cursed it with madness. The final twist? We might never see it coming. If Atlas fragments just before perihelion, telescopes could be blinded by the glare of the sun at the exact moment we need to be watching. The solar corona would swallow the signs of the magnetic collapse until it was too late. One day we'd wake to find the skies glowing blood red with auroras at the equator, communication satellites falling from orbit like shooting stars, and cities plunged into darkness. And in that moment, we'd understand that the real danger of Atlas was never the comet itself. It was the fuse it lit inside the sun, a fuse that might already be burning unseen beneath the roiling surface of our nearest star. Gravity is the great puppeteer of the cosmos, the invisible strings that hold planets, moons, and dust in their endless dance around the sun. For billions of years, the solar system has maintained an uneasy stability, a cosmic truce between giants like Jupiter and delicate worlds like Mercury. But what happens when a rogue outsider like 3i/Atlas blunders into this finely tuned choreography, its ion tail whipping through solar winds, its fragments feeding energy into magnetic fields, and its sheer presence tugging at orbits like a drunken conductor waving his baton? The unsettling answer is that even the smallest disturbance can cascade into chaos on planetary scales. We call this the three-body problem in celestial mechanics, and it has a long, terrifying history of turning near certainty into unpredictability. At first glance, skeptics dismiss the idea. How could one comet, no matter how exotic, destabilize planets hundreds of millions of kilometers away? But the math is merciless. Orbital systems are exquisitely sensitive. Even a nudge of a few meters per second to a planet's velocity can over decades or centuries magnify into millions of kilometers of displacement. Consider the role of resonances. Jupiter and Saturn, the titans of our solar system, lock smaller bodies into predictable rhythms by tugging them at just the right intervals. The asteroid belt itself is carved into gaps by these resonances. If Atlas fragments, or worse, an Atlas-triggered solar eruption, shift Jupiter's orbit by even 0.001%, those resonances change. The asteroid belt could destabilize, sending showers of kilometer-scale bodies inward toward Earth and Mars for tens of thousands of years. The skies of the 22nd century could glow with fire as meteor storms become weekly events, not annual curiosities. And that's only the beginning. Mars itself, already caught between Jupiter's pull and the Sun's whims, could be nudged into eccentricity. Its orbit might stretch further out, freezing its climate into an even more sterile wasteland, or contract inward, making it a hellscape more like Mercury. Earth, caught in the gravitational middle ground, is not immune. If Atlas shifts the distribution of solar mass through its injection of exotic debris, even Earth's orbit could wobble. A variation of just 1% closer to the Sun would raise global average temperatures by several degrees, enough to trigger runaway climate collapse. A 1% outward shift would plunge us into an ice age. Civilization is built on the stability of Earth's orbit. Atlas could turn that stability into a memory, but the real wild cards are the moons. Phobos and Deimos at Mars, Europa and Io at Jupiter, Titan at Saturn. All of them exist in delicate tidal balances. Disruptions in orbital resonance could send them tumbling into catastrophes. Phobos, already spiraling inward toward Mars at 1.8 centimeters per year, might be yanked faster by perturbations, breaking apart into a debris ring in decades rather than millions of years. Titan, Saturn's crown jewel, with methane seas and a nitrogen sky, could shift slightly, altering its tidal lock and destabilizing its climate chemistry. Even our moon, the great stabilizer of Earth's axial tilt, could feel subtle tugs. If Earth's tilt wobbles beyond a few degrees, seasons as we know them vanish. Winters become eternal in some regions, summers bake others endlessly. Agriculture collapses, weather turns feral, and civilization's ability to sustain billions dissolves overnight. Now consider the nightmare of orbital resonance collapse. Imagine Jupiter and Saturn, nudged slightly by solar storms catalyzed by Atlas, entering into a resonance shift that destabilizes their orbits relative to Uranus and Neptune. Computer models of such scenarios suggest entire planets could be ejected from the solar system over millions of years. Uranus, already tipped sideways, could be flung into the void, a rogue planet wandering the galaxy. Neptune's icy orbit could be pulled inward, smashing Kuiper Belt objects into chaotic new trajectories. The Oort cloud, trillions of icy bodies on the solar system's edge, could become a shotgun blast of comets aimed inward, a rain of death that might last for millennia. Humanity could find itself living in an age of perpetual bombardment, where the night sky glows not with stars, but with incoming fire. The sun itself would not remain immune. Orbital chaos ripples back into the star through angular momentum exchange. A storm of falling comets and asteroids, destabilized by Atlas-triggered resonance shifts, would plunge into the sun, feeding it mass, stirring its plasma, and potentially extending its lifetime in bizarre ways. Some astrophysicists speculate that repeated injections of exotic material could alter the sun's fusion dynamics slightly, changing the balance between hydrogen and helium burning zones. This wouldn't make the sun explode. It's too small for that, but it could accelerate its march toward becoming a red giant. Instead of billions of years from now, the first hints of expansion could arrive in mere tens of millions. For cosmic history, that's the blink of an eye. For us, it's a ticking clock set earlier than anyone expected. The cruel irony is that all of this chaos might begin invisibly. Astronomers tracking Atlas might calculate its perihelion, watch its fragmentation, and conclude that Earth is safe because no impact trajectory crosses our orbit. They'd tell the public, "Don't worry, nothing will hit us," and technically they'd be right. But what they wouldn't say, or what they wouldn't realize, is that the real threat isn't collision, but resonance. A gravitational whisper here, a solar eruption there, and suddenly the solar system's architecture shifts. Not in hours, not in days, but in centuries. It would be like termites in the beams of a house. You don't notice until the collapse begins. By the time future generations look up and see skies streaked with fire every night, they'll trace the origin back to one interstellar wanderer, 3I/Atlas, the comet that didn't kill us on impact, but rewrote the rules of planetary destiny. When historians of the far future, if humanity survives that long, look back at the age of 3I/Atlas, they may not remember it as the comet that came and went, but as the moment of fracture, the point at which the clockwork of the solar system began to tick toward a new, unstable future. The truth is, planetary systems are not eternal. They are precarious. Ours has lasted for billions of years, but stability is an illusion, maintained only because no outside hand has yet shoved the delicate gears. Atlas may be that hand. Its passage near the sun is not simply a celestial curiosity. It could be the origin of centuries of cascading instability. We like to think of the solar system as immutable, a cosmic stage set in stone. But orbital mechanics is written in probabilities, not certainties. A tiny shift in angular momentum today becomes a yawning chasm tomorrow. Atlas is not just a comet, it is a messenger of entropy, the whisper of chaos in a system we thought was safe. Imagine the year 2300. Atlas itself is long gone, expelled back into the void of interstellar space, but the legacy of its visit lingers like the aftershock of an earthquake. Jupiter's orbit, imperceptibly altered by solar eruptions catalyzed during Atlas's death spiral, now resonates differently with Saturn. The great stability of the gas giants, the architecture that has shielded Earth from countless cometary bombardments, begins to erode. The asteroid belt grows restless, its fragments tugged into new paths. Instead of a few impacts per century, Earth now faces dozens per decade. Cities build underground shelters, not for nuclear war, but for meteor storms that can vaporize square miles of farmland in seconds. Humanity becomes a civilization of burrowers, hiding from the sky as the heavens turn hostile. The irony is sharp. We dreamed of colonizing Mars and the moons of Jupiter, but Atlas's gift is to lock us to Earth, too afraid to venture outward into a solar system turned minefield. The moon, our eternal companion, may not escape this fate. Subtle shifts in Earth's orbit create long-term torque on the Earth-Moon system. Over centuries, this could destabilize the moon's tidal lock, causing it to drift slightly or even fracture under renewed tidal stress. If the moon's orbit shifts, Earth's axial tilt, the angle that gives us seasons, could wobble chaotically. Instead of regular spring, summer, fall, and winter, we might face millennia of climate madness. Decades-long winters, scorching centuries of summer, rainfall patterns that wander unpredictably across continents. Agriculture, the foundation of civilization would collapse into uncertainty. Survival would depend not on planting cycles, but on stockpiles, genetics labs, and planetary engineering. Atlas, a visitor from another star, would have transformed Earth not by striking us, but by breaking the sky's eternal clock. And then there is the far horizon, the millions of years that stretch beyond the fragile lifetimes of civilizations. Orbital chaos, once unleashed, does not resolve quickly. It amplifies. Resonances build on resonances, like a drumbeat gathering into a war march. Uranus and Neptune, those distant giants, could be shifted into unstable relationships with each other, sending one inward and one outward. Entire planets might eventually be ejected from the solar system, flung into interstellar night as rogue wanderers. Picture Uranus, once a turquoise jewel in our skies, drifting forever between the stars, carrying its moons like a lost family into eternal darkness. That exile would not happen overnight. It might take millions of years, but its seed could be planted in the weak. Atlas brushes the sun, a future in which the solar system no longer has 8 planets, but 7 or 6 or fewer. Perhaps the most haunting possibility is this: Atlas may accelerate the death of the sun itself. Stars burn according to delicate balances of mass and fuel. If enough interstellar material, dust, exotic isotopes, heavy elements gets injected into the solar furnace, the rate of fusion can change. Not enough to turn the sun into a supernova. It lacks the mass, but enough to alter its timeline. Instead of 5 billion years before expansion into a red giant, the sun could swell in 1 billion. For us, that means humanity might never escape into the stars before the oceans boil, the sky turns white, and Earth is consumed. Atlas's true legacy would be to shorten the time humanity has left, cutting away billions of years of cosmic breathing room and forcing our species into a race against stellar death. The greatest irony is that Atlas itself will not remain to see its handiwork. It will be gone, hurled back into the void, leaving only ripples in gravity, scars in atmospheres, and questions etched into human myth. Civilizations may rise and fall, while blaming gods or fate for their endless bombardments and chaotic seasons, never realizing that the origin of their suffering was one alien wanderer that passed too close to the sun centuries before. Atlas's name will fade into dust, even as its fingerprints remain on every planet, every orbit, every catastrophe. If humanity survives long enough to trace the mathematics backward, future astronomers might point to October 2025 as the pivot point, the day when the solar system stopped being stable and started being mortal. Humanity has always looked to the sky for guidance. From the Babylonians charting omens in the movements of Jupiter, to medieval Europe trembling under the sudden blaze of Halley's comet, the heavens have never been just scenery. They have been prophecy, warning, mirror. If 3I/Atlas truly pushes the sun into instability, if the skies erupt with auroras at the equator, if meteor storms become a monthly hazard, then the reckoning will not only be astrophysical, it will be psychological, cultural, and political. The cosmos will no longer be a neutral backdrop. It will become an adversary, and that transformation could shatter the foundations of human civilization. At first, the response would be scientific. Agencies like NASA, ESA, Roscosmos, and CNSA would scramble to deploy every instrument at their disposal. Telescopes would be repointed, satellites recalibrated, billions of dollars funneled into heliophysics. The data would be clear. Something unprecedented had happened to the sun in the wake of Atlas's passage. The rhythms of solar flares, no longer follow familiar cycles. Planetary orbits are shifting by millimeters, then kilometers. Meteor showers increase in intensity. But alongside the data would come the whispers. This was not natural. This was a message. Governments, terrified of losing control, would try to monopolize the narrative. Reports would be classified. Politicians would posture as guardians against a cosmic foe. Planetary defense budgets would explode, dwarfing military expenditures. Humanity would, for the first time in history, begin to treat the sun as both deity and enemy, an object of worship and fear in equal measure. But politics cannot contain awe or terror. Religions would splinter, mutate, or bloom anew. Fundamentalists might proclaim Atlas as an angel of judgment, the herald of apocalypse. Entire sects would emerge declaring that humanity has sinned against the cosmos and that the sun's wrath is punishment. Pilgrimages would form around solar observatories. Cults would attempt to stare directly into the sun during flares, convinced that enlightenment lies in blinding fire. Conversely, techno-utopian movements would frame Atlas not as a curse, but as a test. They would argue that humanity has been forced into maturity, that survival requires the next great leap, interstellar expansion. These groups would demand mega-projects, orbital shields, Dyson swarm prototypes, fleets of arcs bound for Proxima Centauri. Nations might crumble under the weight of both prophecy and engineering ambition, their resources torn between faith and physics. The cultural reverberations would be profound. For centuries, artists have painted the sun as a symbol of warmth, growth, and renewal. But in the era after Atlas, the sun would be reimagined as monstrous, unstable, predatory. Movies would no longer depict friendly dawns, but blood-red skies seething with auroras. Literature would echo with themes of betrayal. The very star that nurtured us now threatens to kill us. Children would grow up learning that summers are not reliable, winters can last decades, and meteors may strike at any time. Their lullabies would be warnings. Their bedtime stories would not be about dragons or ghosts, but about firestorms and shattered moons. Humanity would enter a cultural age, defined not by the earth beneath our feet, but by the hostility of the sky above. And then comes the economic reckoning. A single Carrington-level storm could cause $2 trillion in global damages. Imagine multiple Atlas-triggered superflares hitting in sequence. Power grids would collapse repeatedly. Satellite networks, the nervous system of modern civilization, would be lost. Banking systems, GPS, communication, all gone in pulses of radiation. Whole economies would retreat into localism, cities turning inward as international trade becomes unreliable. Humanity might fragment into a patchwork of fortified enclaves, each with its own defenses against cosmic weather, its own myths about why the skies rage, its own strategies for survival. Globalization, the dream of the 20th and 21st centuries, might dissolve overnight, replaced by a fractured world bound together not by trade, but by shared dread of the sun. Perhaps the darkest reckoning would be existential. Once humanity understands that the solar system itself is unstable, that orbits can shift, moons can shatter, planets can be lost, the psychological foundation of permanence crumbles. We've built our identities on the assumption that Earth will always circle the sun, that the stars will always rise and set. If Atlas proves that even this can change, then nothing is sacred. The cosmos becomes not a home, but a battlefield. Depression, fatalism, and nihilism could spread like plagues. Why build for the future if the future itself might collapse under cosmic fire? Suicide rates might spike, birth rates might fall. The great question of the age would not be how do we live, but why bother? And yet this reckoning might also spark resilience. Humanity has a strange, stubborn gift, the ability to build meaning in the face of annihilation. Faced with a hostile sky, we might double down on survival, turning despair into fuel. Just as the Black Death sparked the Renaissance, Atlas's legacy might ignite a new human epoch, an age of space fortresses, planetary shields, genetic adaptations to radiation. The sun may turn from gentle parent to hostile tyrant, but tyrants have always provoked revolutions. Perhaps Atlas will be remembered not as the destroyer, but as the event that forced humanity to finally grow up, to leave the cradle of Earth, and to accept that the universe is not safe, but it is ours to endure. Exile has always haunted the human imagination. From the banishments of kings to the expulsions of whole peoples, exile has meant more than displacement. It has meant identity stripped bare, a life defined by wandering. Now imagine exile not from a city, not from a nation, not even from Earth, but from the entire solar system. This is the legacy that 3i/Atlas might leave us, not impact, not contamination, not even superflare annihilation, but eviction, a cosmic decree. You cannot stay here, for if the sun itself turns hostile, unstable, unpredictable, poisoned by Atlas's alien chemistry, then the only option left to humanity will be to flee. And flight on this scale is not migration, it is exodus. At first it would sound impossible. The distances alone are staggering. Proxima Centauri, the nearest star, lies 4.24 light-years away, or about 40 trillion kilometers. Even at the speed of Voyager 1's 17 kilometers per second, it would take 75,000 years to get there. But the terror of an unstable sun changes what is possible. Under existential threat, resources flow like rivers. Mega projects that once seemed fantasies. Generation ships the size of cities. Nuclear pulse drives, solar sails kilometers wide, become survival plans. Nations dissolve into a planetary council of engineers and survivalists. The dream of colonizing Mars dies instantly, for Mars under a raging sun is as doomed as Earth. Instead, attention shifts outward, the Oort cloud, the interstellar medium, the faint light of other suns. Humanity ceases to be a solar species. We become galactic refugees. The architecture of cosmic exile would be monstrous in scale. Picture colossal arcs, each housing millions, built from cannibalized asteroids and hollowed moons. Nuclear stockpiles, once designed for war, are detonated behind plates of tungsten to push vessels outward at 10% the speed of light. The Earth itself becomes a scrapyard, stripped of metals, oceans siphoned for hydrogen fuel, mountains carved into launch platforms. Cities collapse not from war, but because their materials are needed for ships. Oceans boil under solar storms, and we drink desalinated reserves recycled aboard the arcs. Civilization compresses into fleets, not nations. The human map changes forever. No continents, only hulls. But exile is not just physics, it is psychology. What does it mean to leave the sun? For all of human history, it has been the axis of our myths, the giver of light, the clock of time. Every culture, every religion, every calendar has been tied to its rise and fall. To abandon it is to abandon our mother tongue, the rhythm of days and years. Children born aboard the arks will never see a sunrise. They will grow up under artificial skies, told that once there was a blazing star that gave life, but turned traitor. To them, the sun will be a cautionary tale, a monster from myth. Humanity's culture will fracture between those who remember the sun with grief, those who curse it as executioner, and those who worship it still, believing the exile to be a divine trial. Religion in exile could transform into solar cults of rage and reverence, each faction demanding that we return or never look back. And then there is the brutal math of survival. Even at 0.1 C, reaching Proxima Centauri would take 40 years, but maintaining life aboard colossal arcs for even 40 years requires technologies we do not yet have. Self-sustaining ecosystems, genetic diversity banks, shielding against interstellar radiation. One hull breach, one fungal outbreak, one power failure could kill millions. Cosmic exile is not simply dangerous, it is Darwinian. Only the most adaptable, ruthless, and inventive will survive. The ships will not be utopias, they will be crucibles. Hierarchies will emerge, shipborne elites controlling food and oxygen, exiled masses bargaining for survival. Humanity will not leave Earth united. We will leave it desperate, fragmented, clinging to life in iron coffins racing through the dark. And the final horror? Exile offers no guarantee. Proxima Centauri may hold no habitable world. The planets we discover may be poisonous, barren, or already destabilized by their own cosmic histories. We may arrive after centuries only to find that no new home exists. In that moment, the bitter truth will emerge. Exile was not salvation, only postponement. Humanity will have traded the firestorms of a dying sun for the endless cold of interstellar night. Our fate may not be settlement, but wandering an eternal pilgrimage through the galaxy, forever fleeing, forever searching, never arriving, and yet, in that wandering, there is a strange, terrible beauty. Perhaps exile is not punishment, but transformation. Perhaps Atlas, in destabilizing the sun, forces us into our true destiny, a species of travelers, no longer bound to one star, but woven into the fabric of the galaxy itself. Exile would be our crucifixion and our resurrection. We would die as a solar civilization and be reborn as an interstellar one. The legacy of Atlas would not be the death of humanity, but its metamorphosis into something vast, tragic, and eternal. Every civilization carries in its bones the assumption of continuity, that tomorrow will exist, that our children will inherit the future, that our monuments will stand against time. But the galaxy does not care about continuity. It is a graveyard, silent and cold, littered with the ruins of ambitions we cannot yet even imagine. And if 3i/Atlas sets us on the path of exile, but that exile falters, then humanity will become just another tombstone in that infinite cemetery. Not by war, not by plague, not by famine, but by distance, by silence, by the slow, merciless erasure of hope in the endless night between stars. Picture the great arcs, once gleaming with the energy of departure, now drifting like derelicts through interstellar space. Their drives sputter, their nuclear stores run dry. Solar sails, once taut and luminous, sag in tatters, shredded by micrometeoroids. Inside, ecosystems collapse, algae tanks sour, crops wither under failing lights. Air recyclers choke on dust and mold. Children grow up malnourished, their bones brittle, their eyes staring at walls of steel instead of horizons. Generations pass in corridors where the concept of sky is a myth told by elders whose ancestors once saw it. The word ocean becomes meaningless. The word forest becomes fantasy. In their place comes a new vocabulary of scarcity. Oxygen rations, hull integrity, radiation dose, language itself withers under the weight of survival. Politics decays even faster. Democracy cannot breathe in airless halls. Instead, hierarchy calcifies. Ship captains become kings. Engineers become priests. The controllers of food, oxygen, and recycling systems hold power absolute. Dissent is not debated. It is vented through airlocks. Religion mutates under starvation and isolation. Some ships worship the idea of a promised world, a Proxima Eden awaiting them. Others embrace nihilism, teaching children that life itself is punishment. Still others descend into cargo cults, revering the machines themselves, praying to the reactors and recyclers as gods. Humanity fractures into 1,000 micro-civilizations, each spinning in the dark, each doomed by the same arithmetic. Resources always run out. And then they begin to die. One by one the arcs go silent. A hull breach wipes out 1,000,000 souls in seconds. A radiation storm sterilizes an entire fleet as they cross the galactic plane. Disease rips through another, unstoppable in closed systems. The dead are ejected into space, not as honored burials, but as necessary sanitation, their frozen corpses trailing behind the ships like spectral flocks. Soon the arcs themselves follow. Power gone, systems cold, they drift forever, silent mausoleums carrying the bones of entire civilizations, monuments not of stone, but of titanium and failure. To any alien eye that stumbles across them in eons, they will look not like survivors but fossils, the silent testimony of a species that tried and failed to outrun its own star. The bitterest truth is this: we may never know if others have tried before. The galaxy is 13 billion years old. Countless stars have lived and died before the sun was even born. How many civilizations were driven into exile by unstable stars, rogue comets, or self-inflicted ruin? How many launched their own fleets of arcs, only to scatter and die in silence, their signals too weak to cross the void? Perhaps the Milky Way is already an infinite graveyard, littered with derelicts from civilizations long extinguished. Perhaps humanity's fate is not unique, but archetypal, the standard ending of intelligence. We will not be remembered as explorers, but as another chapter in the quiet, universal story of failure. And yet, even in that graveyard, there is a strange kind of immortality. For though the ships die, they do not vanish. Their hulls drift for millions of years, frozen archives of DNA, languages, art, and memory. Perhaps no one will ever find them. Or perhaps one day, another species will stumble upon a drifting ark, pry open its airless chambers, and discover the remnants of Earth. They will see our murals, our books, our bones. They will know that once, in a blue system orbiting a yellow star, a people tried to survive the cosmos, and failed. Humanity's grave may be unmarked, but it will not be empty. It will be a whisper in the infinite dark. We were here. This is the legacy Atlas could leave behind, not the death of billions in fire, but the slower, colder death of exile, of distance, of silence. A civilization that outlived plagues and wars and empires, undone not by its own hand, but by the betrayal of its star. A species that fled its home but never found another. The infinite graveyard does not roar, it does not rage, it waits. And in that waiting, it swallows even the brightest dreams of survival. In the end, the story of humanity may be written not in stone, nor in steel, but in light. For all our ambition, all our science, all our defiance against entropy, we are creatures of the sun. Its warmth cradled us into existence. Its cycles sculpted our calendars. Its patience gave us the illusion of permanence. But permanence is a lie. Stars are not eternal. They flare, they rage, they consume, and they die. And when 3I/Atlas came tearing into our system, trailing its alien breath and volatile soul, it was as if the cosmos reminded us, nothing is safe, not even the star that gave you life. The last light is not the sun's, it is ours. There are many ways this tale can end. Perhaps Atlas feeds the sun a banquet of plasma, triggering superflares that strip Earth bare, turning oceans to deserts and cities to ash. Perhaps orbital chaos unravels the planets, flinging moons into their parents, scattering worlds into the dark like broken glass. Perhaps exile fails, and our ships become tombs drifting in silence. Or perhaps, against every odd, humanity endures, splintered, scarred, but alive, living as wanderers in the galaxy, carrying forward the memory of a blue world that once circled a golden star. Each ending is different in its detail, but all converge on the same truth. 3I/Atlas marks the end of our innocence. For thousands of years, humans believed the sky was reliable. The sun rose, the planets wandered, but predictably. Comets were omens, but they always left. Atlas shatters that belief. It shows us that even the sun can be provoked into madness, that even the solar system can be destabilized by a single intruder. It shows us that the universe is not a clock, ticking forever in perfect rhythm, but a storm, chaotic, violent, indifferent. And in that storm, we are not masters, we are passengers. The last light is the aurora over equatorial skies, as Earth's magnetosphere collapses. It is the fiery rain of meteors streaking across ruined cities. It is the glow of reactors aboard generation ships, dwindling as exile stretches into despair. It is the faint candle of human art, human memory, human stubbornness, flickering even as the cosmos presses down. Perhaps it is extinguished. Perhaps it survives, carried to another star. Either way, it will shine only briefly against the backdrop of eternity. The galaxy is vast, old and silent, and our light was always going to be temporary. And yet, temporary does not mean meaningless. A firefly's glow lasts only a night, but in that glow is wonder. Humanity's light may be brief, but it has already burned brighter than most things the cosmos has ever known. We split atoms, built machines that think, peered into the birth of galaxies billions of years away, all from a fragile rock orbiting a fragile star. If Atlas ends us, then let it also immortalize us. Let future wanderers, human or alien, find our ruins and see in them not failure, but defiance. For what is life in a universe of endless darkness, if not rebellion? The last light is not tragedy, it is testament. Testament that once, in the brief span of cosmic time, intelligence bloomed on Earth, sang to the stars, and refused to cower. If Atlas is the herald of our end, then our answer is not silence. It is the blaze of cities, the launch of ships, the stubborn survival of stories. The comet may pass, the sun may rage, the planets may fall, but the memory of humanity, the fire we carried into the dark, will linger, if only as a whisper in the infinite. And so the saga closes where it began, with a question. What happens when 3I/Atlas gets too close to the sun? The scientific answer is chaos, plasma storms, orbital shifts, superflares. But the human answer is something deeper. What happens is revelation. Revelation that we were never safe. Revelation that survival was always fleeting. Revelation that in the face of annihilation, our greatest act was not fear, but the choice to burn brightly, however briefly, in the vast silence of the cosmos. That is the last light, not the comet, not the sun, us,